I am going to show you the example. Diagonalize the matrix 1 0 0 0 3 minus 1 0 minus 1 3. This is the working rule to find the diagonalization of a matrix. Find the eigenvalues, find the eigenvectors, form the model matrix and find B inverse AB, the product. Now, first thing, to find the eigenvalues, we need to find the characteristic equation. How will you find the characteristic equation? The first step, as I told you earlier, by using the formula lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0, or by determinant of A minus lambda I equal to 0. Now, this is the given matrix. So, 1 minus lambda 0 0 0 3 minus lambda minus 1 0 minus 1 3. See, since we have many zeros in the matrix, we can directly use the determinant of A minus lambda I formula. So, the first step will be, how will you do it? To find the determinant, 1 minus lambda into 3 minus lambda into 3 minus lambda, which will give you 3 minus lambda the whole square, minus 1 into minus 1 plus 1, again you will get it as minus 1. Now simplify everything, 1 minus lambda into 3 minus lambda the whole square. So you will get it as 9 minus 6 lambda plus lambda square minus 1. Now simplify it, 9 minus 6 lambda plus lambda square minus 1 minus 9 lambda minus into minus. First take the first element and multiply with everything, and take the next one and multiply with everything. You will get it as minus 9 lambda plus 6 lambda square minus lambda cube plus lambda. So when you simplify this, you will be getting it as lambda cube minus 7 lambda square plus 14 lambda minus 8. Therefore, the characteristic equation is lambda cube minus 7 lambda square plus 14 lambda minus 8 equal to 0. Now, first step, find the eigenvalues. To find the eigenvalues, we have found out the characteristic equation. How will you do it? By applying the synthetic division. 1 minus 7, 14 minus 8. As I told you earlier, how will you find the synthetic division? You will take the roots randomly, that is minus 2, minus 1 and then 2, 1 and then anything 3, so on, minus 3, like that. Now, first step, I am going to solve it with 1. Always put 0 for the first element. You will get 1 plus 0 will be 1, and then multiply with this, with the root. 1 into 1, 1, minus 7 plus 1, minus 6, minus 6 into 1, minus 6. Again this will give you 8, 8 into 8, 8 into 1 will give you 8, 8 minus 8 is 0. Are you getting the remainder as 0? Therefore, we can take the root as 1. Therefore, we can say lambda is equals to 1 is a root. If suppose, if you are not getting the remainder as 0, then go for the next one. Next root you can go for minus 1. Even in minus 1, if you are not getting the remainder as 0, then go for the next root minus 2 and then 2. Within 3 itself you will be getting the roots. If not, if you are going beyond 3 or minus 4 or 4, then the characteristic equation what you have found out is wrong. So, once you are finding out the roots by using the synthetic division, maximum you have to go for the roots minus 3 to 3. If you are going beyond that, then go check for the characteristic equation. You must have made mistake in the characteristic equation. Now, you have got lambda is equals to 1 is a root. You have got one of the root. Now, you need to get the next two roots. How? By factorizing the equation. Lambda square minus 6 lambda plus 8 equal to 0. When you factorize it, lambda minus 4 into lambda minus 2, which is equals to 0. Therefore, lambda is equals to 2, 4. Therefore, the eigen values are 1, 2 and 4. Therefore, the eigen values are 1, 2 and 4. We have got the eigen values. Now, first step is over. Now, what is the step 2? We need to find the eigenvectors. How will you find the eigenvectors? By using the eigenvalues 1, 2 and 4. To find the eigenvector, what is the condition? A minus lambda I into x bar is equals to 0. So, this is the matrix A. So, how will you get it? 1 minus lambda 0, 0, 0, 3 minus lambda minus 1, 0 minus 1, 3 minus lambda into x1, x2, x3, which is equals to 0, 0, 0. Now, what is the first case? Case 1, when lambda is equals to 1. You can find out in any order. You can even take when lambda is equals to 2. Any order you can take. But the final answer you have to get it as the diagonal elements as the roots 1, 2 and 4. So, we can find out the eigenvectors in any order. Now, when you substitute lambda is equals to 1, what do you get? Directly I will write the reduced matrix. 1 minus 1 will give you 0, 0, 0. And then next one 0, this will give you 2 minus 1, 0 minus 1 and finally here you will get it as 2. x1, x2, x3, 0, 0, 0. See here in the first equation you are getting it everything as 0. So, you can write down the second and the third equation. You can write it as 0x1 plus 2x2 minus x3 which is equals to 0 and similarly 0x1 minus x2 plus 2x3 is equals to 0. Now, here the assumption method is not possible because you may get it in fraction. In that case, to avoid fractions, I am going to do it by rule of cross multiplication. Solving by rule of cross multiplication. Now, to find out the rule of cross multiplication, I will teach you some easy method. We need to take it B, C, A, B. solving the equation, if you are taking this as equation 1 and 2, solving the equation 1 and 2 by the rule of cross multiplication, I am going to use the method BCAB. That means the coefficient of x2 here, you will take this as A, B, this as A, B, C. Now, when you take this as B, what is the coefficient of x2 here? 2. And similarly, what is the coefficient of x3 there? -1. And A will be 0 and again B will be 2. This is for the equation 1. Move on to the equation 2. Same way, -1, 2, 0, -1. Now I am going to do the cross multiplication. x1 divided by 2 into 2 minus -1 into -1. This will give you 4 minus 1, which is equals to next one, x2 divided by, this will be x1 and this will be x2 and this will be x3. Now again x2 minus 1 into 0 minus 2 into 0, which will give you 0 minus 0, and x3 will be again 0 into -1, 0 into 2. So again 0 minus 0. So what are the values you are getting it? x1 divided by 3, x2 by 0 and x3 by 0. So therefore the eigenvector is, for the corresponding lambda is equals to 1 is, you can write this as 1, 0, 0. When you divide by 3 throughout, you will get it as 1, 0, 0. So I told you in the earlier session that all the eigenvectors cannot be zeros. Any one value you can get it. So this is correct. Now we will move on to the second case. Case 2. What is the second eigenvalue? Lambda is equals to 2. When lambda is equals to 2, what do you get? Directly I will substitute it and get the reduced matrix. I will get it as -1, 0, 0, 0, 1, -1, 0, -1, 1. x1, x2, x3, which is equals to 0, 0, 0. So from this we can get it as minus x1 is equals to 0. The second equation, x1 minus x2 is equals to 0, and the third one minus x2, this is x2 minus x3, and this one minus x2 plus x3 is equals to 0. You have got it 3 equations, 1, 2 and 3. Now solving this, we need to get the value of x1, x2 and x3. So from 1 we can say that x1 is equals to 0. From equation 2 we can write x2 minus x3 as x2 is equals to x3. Now assume x2 is equals to 1. Obviously x3 will also be 1. Therefore the eigenvector is, is 0, 1, 1. So we have got the eigenvector for 2 cases. Similarly, we need to find the eigenvector for the third case. Similarly, you will substitute lambda is equals to 3, and after simplifying everything you will get 3 equations. After getting 3 equations, once you simplify it, by the rule of cross multiplication or by assumption method, you will get the third eigenvector. Here for the third case, I will directly write down the third eigenvector. So, for the third eigenvector, that is for the case 3, that is when lambda is equals to 4. In that case, the eigenvector is 0, 1, minus 1. So, we have got 3 eigenvectors for the corresponding 3 eigenvalues. Now, step 2 is over. Now, we need to find out the step 3, form the modal matrix. What is the modal matrix? Columns are the eigenvectors. So, we have got this eigenvector 1, that is x1. This is the second one, that is x2. This is the third one, that is the x3. Now, what is the modal matrix? Always it is denoted by B. B is equals to, you need to write these eigenvectors in column wise. So, how will you write down? 1, 0, 0, 0, 1, 1, 0, 1, minus 1. And I want to make one thing clear, you can write the columns in any order. You can write the eigenvectors, the first eigenvector even you can write it as the third column, any order. But you should not write it in row wise. Always the eigenvector should be write it in column wise only. So, from this we have formed the modal matrix B. What is the step 4? Find the B inverse. Step 4, find B inverse. How will you find B inverse? What is the formula? Adjoint of B by determinant of B. What is adjoint of B? Transpose of the cofactor matrix. First we need to find the cofactor matrix and then we will take the transpose of that. Finally, we will find out the determinant. Okay. Now, first let me find out what is determinant of B. This is the matrix B. From this, when you find out 1 into minus 1, you will, as I told you earlier, you will leave the corresponding row and the column to find the determinant. 1 into minus 1, minus 1. So, you will get it as 1 minus 1, which is equal to minus 2. Therefore, determinant of B is minus 2. Now, to find the adjoint of B, you need to find the cofactor matrix. Cofactor matrix B, which is nothing but B11 minus B12, B13 minus B21, B22 minus B23, B31 minus B32, B33. So, I will show you some examples, how to find out B11 and B12 so on. The minor of each element, that is the cofactor matrix. First one, B11. What is B11? This element. You will leave the corresponding row and column. What is left out? 1, 1, 1, minus 1. So, you will get it as minus 1, which is nothing but minus 2. Similarly, B12. For B12, you will leave the corresponding row and column. This is B12, row and column. You will get it as 0, 0. So, 0, 1, 0 minus 1, 0 minus 0, you will get it as 0. B13, Again for this element you will leave this row on the column, you will get it as 0 1 0 1, which is again nothing but 0. So for the rest you can do it similarly. For this one the rows and the columns are left out 0 0 1 minus 1. So directly I will write down B12 will be 0 and then B22 will be 1 and then B23 will be 1. For the next one B31, again for the third row, for this element you will leave the corresponding row and the column. What is left out? 0 into 1 minus 1 into 0, again which will give you 0, and then B32 will give you 1, B33 will give you minus 1. After finding out all these, you have to write the inverse of the matrix. So we have found out the cofactor matrix now. What is the transpose of this? Transpose of the cofactor matrix. Which is equals to, this is what is given, you can directly write the transpose of this. So what is it? Minus 2, and then next one B12 is 0, anyway it is going to be 0, 0, 0. Next one is B21, for B21 it is 0, and then next element is 1, and then here it is minus 1, and for the final one 0, minus 1 and minus 1. So finally therefore B inverse is equals to adjoint of B by determinant of B. So determinant of B already we have found out as minus 2. So minus 1 by 2 into minus 2, 0, 0, 0, 1, minus 1, 0, minus 1, minus 1. We have got B inverse. Now what is the final one? Last step, find the product B inverse AB, which will give you the diagonal form of the matrix. We have found out B inverse, minus 1 by 2, minus 2, 0, 0, 0, 1, minus 1, 0, minus 1, minus 1, and then A, that is the given matrix A, 1, 0, 0, and 0, 3, minus 1, 0, minus 1, 3. Next last matrix, the matrix B, that is minus 2, the matrix B is 1, 0, 0, 0, 1, 1, 0, 1, minus 1. So when you multiply all these, you will get the diagonal form of the matrix, that is 1, 0, 0, 0, 2, 0, 0, 0, 4. So from this you can see that the diagonal elements are all the eigenvalues, the rest of the elements are all zeros. This is what the diagonal form of the matrix. So here no formulas, nothing, you can just go according to the working rule, that is the procedure. What is the first step? You will find the eigenvalues. Step 2, you will find the eigenvectors, and then step 3, form the model matrix. What is the model matrix? Whose columns are the eigenvectors. 3 eigenvalues you have found out, corresponding eigenvectors you have found out. Those eigenvectors you will write it in column wise, and also you can change the order. Accordingly you will get the final answer. The eigenvalues will be changed here. So any order you can write the eigenvectors, and that will be the model matrix. Step 4, find the B inverse. What is the formula for B inverse? Adjoint of A, B by determinant of B. Whatever you are taking, matrix B or anything. So, B inverse is equals to adjoint of B by determinant of B. What is adjoint of B? Transpose of the cofactor matrix. And finally, you need to find the product B inverse AB will give you the diagonal form of the matrix. I will teach you one simple way to find out the product form. First, always go for the B inverse A. You first multiply with these two and then whatever the resulting matrix you are getting it, and from that you multiply the last one. This will give you the easy way for finding out the diagonal values as the eigen values.